Welcome back. This vodcast is on writing sequences explicitly. Remember that in the previous vodcast we were looking at sequences and writing them recursively. And remember, recursive means that each value can only be found by finding the previous value in that sequence. Well, what we'd like to do is we actually like to look at the sequence, the arithmetic sequence. U sub 1 is equal to 8, and U sub n is equal to U sub n minus 1 plus 4, meaning it's going up by 4 each time. What we want to do is we want to actually find U sub 10. Well, the best way we have of doing that is calculating U sub 1, 2, 3, all the way up to 10. So let's go ahead and do that. Let's use our calculators. Let's start with 8. Press enter. And we're going to add 4 each time. So plus 4. So 8 is the first one, then count. Second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, and 10th one. And so we get U sub 10 is equal to 44. Well, let's look at these values again. U sub 1 is equal to 8. U sub n is equal to U sub n minus 1 plus 4. And I have them in this chart over here. So in 1 it's 8, 2 it's 12, 3 it's 16, and we keep on going. What I'd like you to see is if you look at it this way, we can see that each time we're going up by 4, obviously, because that's going to be part of the sequence. We'll go back to a linear equation. Remember, the general form for a linear equation is y is equal to mx plus b. M is the amount that's going up or down each time. So in this case, m is going to be equal to 4. Well, we have a problem, and the problem is that the initial value that we start at is not 8, because if I do 4 times 1 plus 8, I'm actually getting 12. So what I actually have to do is actually adjust this sequence by putting in 4 times x minus 1. And now, if x is equal to 1, y is equal to 4 times 1 minus 1, which is 0, which is 8. When x is equal to 2, I'm going to have 4 times 2 minus 1, which is 1, and so I'm going to get 12. So by putting in this x minus 1, this sequence now works. What I'm going to do is actually turn it around a little bit, just because the way we normally write a sequence is going to look something kind of like this. A sub n is equal to 8 plus 4 times n minus 1. So what does it mean to write a sequence explicitly? It means that you give me any value for n, and I will find u sub 10, or in this case, a sub 10, directly. A sub 10 is going to be equal to 8 plus 4 times 8 minus 1, which is going to be equal to, oops, not 8, but 10. 8 plus 4 times 10 minus 1, which is 9. And 8 plus 36 is going to give me the 44, which is what we got before. So let's summarize that. To write an arithmetic sequence explicitly, we're going to use the form a sub n is equal to a sub 1 plus d times n minus 1. A sub 1 is that initial value. D is the common difference. So it's really not too hard. Let's practice that. Excuse me. Let's write these arithmetic sequences explicitly. Here's the formula up here. The first one has been done for you. So to write this sequence explicitly, a sub 1 we can see is equal to 2. It's going up by 7 each time. So a sub n is equal to 2 plus 7 times n minus 1. I'd also like you to find a sub 8. And when you plug 8 into this expression, you will get a sub 8 is equal to 51. Pause this video and actually do the remaining ones, and then we'll come back to this. Okay, we're back. The next sequence is going to be a sub n is equal to 4, the starting value. We can see that it's going up by 12 each time, so it's 12 times n minus 1. Plug in 8, and we're going to get a sub 8 is equal to 88. For the next one, a sub n is equal to negative 3 minus 2 times n minus 1, because we can see this is actually going down by 2 each time. Plug in 8, and we get a sub 8 is equal to negative 17. The last one, same idea. The initial value is 4.5. It's going up by 2.5 each time. Remember to take a number and always subtract the previous number, and we're going to get our common difference, which in this case is going to be 2.5. A sub 8 is equal to 22. Now let's turn to writing a geometric sequence explicitly. Remember, the geometric sequences have this common ratio. Common ratio here, we can see that we have 6 over 3, 12 over 6. A common ratio is going to be 2. U sub 1 is equal to 3. So if we write it recursively, we can see the u sub n is equal to u sub n minus 1 times 2. Easily done. Let's write it explicitly, and what I want to do is look at this chart. I have this chart of values. When n is 1, we have 3, n is 2, we have 6. So I've rewritten this sequence now. And now let's look at these values in a different way. In order to get 6, it's 3 times 2. In order to get 12, it's 3 times 2 twice. In order to get 24, it's 3 times. 48 is 3, and then 4, 1, 2, 3. I think I have an extra 2 in there. 4 times. What I want you to notice, not that, but I want you to notice that the number of 2's being multiplied is 1 less than n. No 2's, 1 2, and we keep on going. Lock that one out. So if we're going to write a sequence for this explicitly, what it's going to look like is something kind of like this. A sub n is equal to 3, the initial value. 2 is the common ratio, and I'm putting it to the n minus 1 power, because it's always 1 less 2 than all the other ones. So writing sequences explicitly really comes down to this. Something to put into your notes. Explicit formula for arithmetic sequences is up here. Explicit formula for geometric sequences is right here. A sub 1 is the initial value. D is the common difference. R is the common ratio. So I recommend that you go ahead and put that into your notes, and then let's practice this one more time. And let's practice writing geometric sequences explicitly. So write an explicit formula for each of these sequences, identify the sequence as arithmetic or geometric, and then find either the common difference or the common ratio. So let's look at the first one. We can see that negative 6 minus a minus 2, minus 18 minus, so it's not going up or down by the same amount, but if we look at negative 6 over minus 2 or negative 18 over minus 6, we see that there is a common ratio of 3. It starts with negative 2, so that's going to be our sequence. The next one, we can see here that our common ratio is going to be negative 5. So we're going to have R is going to be negative 5. Our starting value is negative 2. This one's a little bit harder. Again, with fractions, we can take any two fractions. Take a fraction, take 1/2, divided by the previous value. So we get 1/2 times the reciprocal of the bottom, which is 4/3, which is 4/6, which is going to turn out to be a common ratio of 2/3. Our initial value is 9/8. Same idea, just a little bit harder. And that last one, that should be a negative 12. Starts out with negative 12, and it's definitely not going up by -5, so let's just cancel that one right out. But that should give you enough practice. Take care.